Okay, guys, we're going to explain the exercises on the math practice of last Friday or last Thursday, and we're going to see one by one the exercises included in that practice. We're going to begin with number one. We're going to find the union of B and C. Remember that the union of two intervals is the set of numbers, or the interval that includes elements or numbers in B, numbers in C, or both. So we're going to put together all the numbers in B and C. So let's see what it will be the graph of the interval B. The interval B begins at 2. So we're going to graph B and C above, and the union is going to be on the line. So B is, let me see, it's about here. So we make a dot in here that is open, and we have to color all the way through the right. So we're going to draw a ray that it goes to the right, in that direction, to the right. So it covers the whole number line. If you can make the ray that it goes all the way through the right, passing even your number line that you have drawn. This is the interval B. Now let me graph the interval C. The interval C is the one that goes from -5, let me locate -5, up to 5. 5, that is over here. So a little bit below, and let me switch color. I'm gonna graph not on the number line, a little bit below the interval B that I already graphed, but not on the number line. I'm gonna graph the interval C that it goes from -5 up to 5. Both extremes are not included because it's using parentheses indicating that the extremes -5 and 5 are not included. So this will be the interval C, from -5 to 5. And now we're looking for the union. When we look for the union, what we need to do is to put on the same number line the numbers in interval B and the numbers in interval C. And as you can see, if you put together all these numbers, it goes from -5 to 5, that is interval C, with the numbers in B that it goes from 2 to 5, they will cover on the number line all the numbers that begin at -5 and go all the way through to the right. So it means to the infinity. So let me make a circle at -5 here, and let me shade. Let me change coloring here, and let me again. I'm gonna circle -5, and since I'm putting together all this, like I'm putting down both intervals on the line that is below number line, and if they will cover from -5 up to 5, that would be the union. Points in common and not in common. So all in interval B and C in the same number line. So they will cover from -5 to positive infinity. That will be the graph of B union C. So this will be the graph. And now what it will be, this is the graphic notation. We solve this by making a graph. So what it will be, the interval notation of this expression. The interval notation will be from -5 without including it up to positive infinity. Positive infinity. That will be the interval notation. None of the extremes is included. The infinite is never included. And the inequality notation, it will be from, we need to, okay, all the values are on the right of -5, so the inequality notation will be x must be greater than, just greater than, because it's not included the 5, x greater than -5. And this will be the solution of the first exercise in the math practice. Let's continue with the second one. In the second one, the intervals that we need to use are a and c. The interval a goes from -infinity to 3, and c from -5 to 5. Like we did before, we're going to graph above A and C. And in this case, we're going to find the intersection. The intersection is the sets or the interval of numbers in common, the numbers in common to A and C. So let me begin drawing the graph of A, and A goes from -infinity up to 3. So let me locate 3. 3 is about here. And since this is the interval that comes from -infinity, I'm going to draw an arrow that it goes or is pointing to the left because it's coming from -infinity. So from -infinity up to 3. So this will be my interval all the way through to the left. This is my interval A, from negative infinity to 3. Now let me graph the second interval that it comes from negative 5, let me locate negative 5 on my number line, up to 5. I locate both values, and the interval goes from negative 5, I make a circle above, at the same level of 5, negative 5, and the same with 5, a circle at the same level of 5. And I join these two because they are covering all the values between negative 5 and 5. And this will be the interval C. Now, how do I find the intersection? What we're looking for the intersection are those numbers, in this case interval numbers, in common. And if you notice that this graph, you can move them, they will overlap. And they will overlap from negative 5, all this region in here, guys, from negative 5 up to 5. So it means that my intersection goes from negative 5 up to 3. And I need to make a decision. Do I include negative 5? Okay, the intersection, it means that they're in common. In the interval in A, negative 5 is included because it's in the interval from negative infinity to positive 3. But in B, it is negative 5 is not included. So, since they must be in common, the intersection, so in the intersection, in the final intersection C is not included. Negative 5 is open. And let me see at the right, with the value 3, is not included in A, is part of C, it is included, but it has to be in both. So it has to be also open. So my solution, it goes from negative 5 up to 3. Up to 3. So I make the graphing, and this will be, I just want to make one correction that I think that in my exercise the 8 was from a negative infinity to positive 3, including the 3. So let me make that change at this moment. So this will be including it. So if it is included here, it will be included. And now we need to make a change in the intersection, because now I'm talking about the extreme 3. If it's included in 8, because I make a correction in here, let me make it again. So in here I had it like it wasn't included, but it is included. So it's a bracket. So that's why at this moment we're making the dot in 8 solid. And we repeat the intersection, the process to find the intersection, and now we make a decision with extremes 3. It is part of A because it's solid in A, and also it's part of B because the interval in C goes from negative 5 to 5, so it's included in 3. So in here at 3, guys, this value should be included. So finally my interval goes from negative 5 to 3, and this will be the intersection. This is the interval A intersection C. A intersection C. And what it would be in this case, the interval notation for this exercise. The interval notation. The interval notation goes from negative 5 without including it up to 3. That is, so let me correct it here. I said that it's not included and I'm including it. So again, it goes from negative 5 not included up to 3 that is included. And what will be the inequality notation for this? The inequality notation, it will be, since it has two extremes, I need the double inequality to describe all the x between. So the x is between negative 5 and 3. And in this case, since the value 3 is included, I just need to say negative 5 less than x less than or equal to 3. And this will be the second exercise. Let me continue with the next one. And the next one, we need to find B union C intersected with A. If you remember, guys, we already know what is B union C. We have is one of the exercises. It's exercise 1. And what we found in B union C is that the interval, or the union, is represented by the interval negative 5 to positive infinity. That is the interval B union C. And the interval A is from negative infinity, is the interval that goes from negative infinity up to 3, including the 3. We use a bracket. So we need to put this together in this exercise. So as we proceed before, we're going to graph above the number line B union C, below that one, but not on the number line A, and then we're going to find the intersection. How do I know what is the order of the, because I have two operations here, a union and intersection. I'm gonna leave this for my work for the parentheses. In parentheses, I see B union C. So that's the first one that I'm gonna find. This is the first one that I'm gonna find, that I have it already because we did it before. And then I'm gonna find the intersection with A. So that's the way that we proceed. So let me graph B union C here. That is, I repeat, the answer that we get in exercise 1, and this interval goes from negative 5, let me locate negative 5, up to positive infinity. Negative 5 is not included, so I'm going to make it above. I'll make it a circle, open, and since it goes all the way through the infinity, I'm going to shade to the right. So it goes all the way to the right. I make this, let me continue doing all the way through the right, and this will be the interval that represents B. Let me make this clear. This interval is the one that goes from negative 5 to positive infinity, and this is B union C because we just found it before. Now let me graph the interval A, and the interval A is the one that comes from negative infinity up to 3. From negative infinity up to 3, let me locate 3, it's over here. So it goes from, this interval comes from negative infinity, so let me make a circle in here above, and it's solid above the number line, and this graph comes from the negative side, so let me draw an arrow that goes to the left, indicating that my interval comes from negative infinity to positive 3. And this is what I have. This is the interval. This is the graph of the interval A. Now again, we have an intersection, is what we need to proceed to finding here. In the intersection, if we can overlap the graph, we will see that this graph has points in common. That's the intersection, points in common from this value negative 5 up to the value 5. And how do I put this on my number line? Okay, I'm going to circle the extremes, the points in common. It goes from negative 5 up to 3. And I need to make a decision. Should I include negative 5? If you notice, negative 5 is not part of the interval above B union C. It's not part of it. It's part of A, but it has to be in both. So that's why I leave it open. The other point, 3. It is included in A because it goes from negative infinity to 3, including 3. And it's also part of the interval B union C. So in this case, the extreme 3 must be included. So it's a solid dot. And finally, I'm going to shade all the values. I'm going to take all the values in between the values that we just found. And the values that we found are negative 5, the points in common, or the numbers in common goes from negative 5 up to 3. So this region in here, let me make it clear. This is the region. So the interval notation for this interval that we just found, the interval notation goes from negative 5, not included, up to 3, that is included. And the inequality notation, it will be, since I have two extremes, I need to say that the x is between negative 5 and 3, and it's included at 3, so it's negative 5 less than x, less than or equal to 3, and this will be the third exercise. Let's complete the next one, C minus A. And let me explain what it means, C minus A. C minus A means the following: numbers that are in C but not in A. That is the meaning of C minus A. So keep that in mind. We're going to proceed exactly the same as we did before. We're going to need to graph the interval C. The interval C, that is the one that goes from negative 5 to 5. and the interval a, that is the interval that goes from negative infinity to positive 3, including 3. Okay, so this goes, let me proceed graphing one of the intervals. Let me graph C. Again, all the intervals C and A, both intervals must be graphed above. So let me graph C. The interval C goes from negative 5 to 5. So let me graph that above. Negative 5 is over here. The dot for negative 5 above, aligned with negative 5. It is open, so I don't shade it. Same happens with 5. I leave it open, and I'm gonna shade all the values in between. So let me draw the shading, or just let me draw a segment that is equivalent to that. This would be the graph or the interval that goes from negative 5 to 5, that we call it C. Now let me draw, use another color, let me draw the interval that goes from negative infinity up to 3. So 3 is over here. It is including the 3. It's including it. Let me switch color. This is including negative 3 here. And since it comes from negative infinity, let me shade the portion or the region that it goes to the left. So my arrow comes from the left. So I draw an arrow, or a ray. This is actually a ray, and that is pointing to the left. So my graph comes from negative infinity up to 3. And this interval is called A. And now, finally, let me see the idea, C minus A. I'm going to graph on the number line C minus A. And we take the following in consideration. What are the numbers that are in C, in the interval C, that are not in the interval A? If you see that carefully, you will notice that the portion that it goes from negative 5 to 3, it is part of the intersection. So these values from negative 5 to 3 are in both intervals. But we need those numbers that are in C that are not in A. And if you notice, those values begin from this number in here. So this is the interval, this one over here, that it will be C minus A. In that interval, you can find, in that piece, you can find the values that are in C that are not in A, in this portion over here. Okay, so I think now that you can see it, so that portion is C minus A. All the values that goes from 3 to 5, those numbers are not in, are in C, but are not in A. Now, let me take care of the following. Should be 3 included in my graph? Let me make a dot. So my interval goes from 3 to 5. And the question at this moment is, should I include 3 or not? If you notice, in C, 3 is part of C, and also is part of A. So since it's part of both, and it says numbers that are in C but not in A, we shouldn't take in consideration the 3 because it's in both of them, and they have to be not in this interval, in the new interval C minus A. So 3, we're going to leave it open because it's in both, and I need that they belong to C but not to A. And in the other extreme, we have 5 that is only in C, and it is open, so I leave it open. And finally, let me shade in between. The shading in between, it will be from negative 3 to 5. And now let me take care of the interval notation. interval notation, that it will be from 3 to 5 without including any of these values. And also the inequality notation, that it will be all the x values that are between 3 and 5 without actually including 3 or 5. And this would be the solving of the exercises in the math practice that we did with you, or that you did in class.